Good afternoon, students. Let us move the module number 2, the continuation module number 2, network theorems. The next theorem is Thevenins theorem. All theorem finally reduce the circuit to find out the voltage and current with respect to the circuit diagram. But here statement is very big. Thevenins theorem, very simple. First, remove the impedances or combination of linear bilateral circuit elements. The common linear bilateral circuit elements, active source require a connection with complexity connected to load ZL. Remove the load impedance. Replaced by single two-terminal network consisting of the single voltage source VTH. Okay, next to find out the VAB or VTH. This is Thevenin's voltage and single impedance Z equivalent. That is equivalent circuit diagram Thevenin Z equivalent in series with voltage source across the two terminals of the ZL. The VTH is open circuit voltage, the measured in two terminals interested with the load impedance ZL removed. First to ZL removed, the next you find out V Thevenin's open circuit voltage with including two terminals interest. The voltage also called Thevenin's equivalent voltage, V Thevenin's. The Z equivalent is equivalent impedance of the given network viewed through the terminals where the ZL is connected. ZL is removed of all the active sources are replaced by their internal impedance. If the internal impedance are not known, the independent voltage source are to be replaced by the short circuit. It means independent voltage source replaced by short circuit. Impedance is not known. Independent current source must be replaced by open circuit. This is called Thevenin's. Explanation of Thevenin's theorem. How to work the Thevenin's theorem? It is a concept of Thevenin's equivalent across the terminals. Across the terminals means across the terminals AB. First, the ZL will be removed. First step. The terminals AB or terminals are load impedance ZL is connected. ZL is connected. Thevenin's equivalent across the load terminals AB. First you connected load side, that is ZL. Next, all impedance will be single impedance Z equivalent. Z1, Z2, Z3. It means equivalent impedance. Equivalent impedance V Thevenin's across the AB, that is ZL. It means V Thevenin's is a voltage, open circuit voltage. This is Thevenin's voltage. This is found very, very important. V Thevenin's voltage with all impedance will be equivalent impedance. The VTH is a voltage obtained across the terminals AB. The ZL is removed. Hence, it is open circuit voltage. Once your ZL is removed, this circuit will be open. Why open? To find out VOC or VTH. Very clear. Why remove this portion? This is you calculate open circuit voltage in load side. That is VOC or VTH. While Z equivalent is equivalent impedance viewed through the terminals AB, the ZL is removed. Voltage source replaced by short circuit. The current source are open circuit. Next diagram. This VTH. This is open current source. While obtaining VTH, any of the integral simplification techniques may be used. The circuit is replaced by Thevenin's equivalent across the load terminals. Across the load terminals. This is IL. IL equal to VTH. ZL plus Z equivalent. Why ZL? The load side ZL with the total impedance, equivalent impedance, that is Z equivalent. By using this theorem, current through any branch of the circuit can be obtained. Creating that branch impedance to the load impedance, obtain Thevenin's equivalent across the two terminals of the branch. Okay, what are the steps to find out the Thevenin's theorem? Steps applied to the Thevenin's theorem. First step, remove the branch impedance through which current is required to be calculated. Very clear. First, to remove the branch impedance through which current is required to be calculated. Step number 2, calculate voltage across these open circuit terminals by using any of the network simplification techniques. This voltage is Thevenin's equivalent voltage. You find out any methods to reduce the circuit. You find out just to find out VTH, that is open circuit voltage. Step number 2. Step number 3, calculate equivalent impedance Z equivalent as viewed through the two terminals of the branch from which current to be calculated by removing the branch impedance. First, branch impedance through the current is required to be calculated. Step number 1. Step number 2, calculate voltage across open circuit terminals using any of the network simplification techniques. This voltage is called Thevenin's equivalent voltage. Third number, calculate. Step number 3, calculate the equivalent impedance Z equivalent as viewed through two terminals branch from the current to be calculated by removing the branch impedance and replacing all independent source by the internal impedance. It means all independent source by their internal impedances. You Z1, Z2, Z3 equivalent to Z equivalent. Step number 2, draw the Thevenin's equivalent showing the voltage source VTH with the Z equivalent in series with it. Across the terminals, the branch through which is current to be calculated. Reconnect and branch impedance now. Let it be ZL. Required current through branch, that is I equal to V by R only, but here the impedance Z equivalent plus ZL plus Z equivalent. I equal to VTH, that is voltage by impedance ZL by Z equivalent. Okay, problem next class, next video lecture. Thank you.